Hello, pre-calculus students. All right, hi guys. We're gonna tackle a couple of problems together real quick, and kind of the goal I have for you for watching these two examples is to just kind of kickstart you into your homework for this week. So one of the problems is taken from your worksheet where you'll be eliminating parameters with conic sections and sketching those. And then the other problem is taken from your textbook. And then I also wanted to mention that in this week's folder, you are going to find keys for problems from pages 1 through 5 or 2 through 5 from your Unit 9 workbook. So a link to your Unit 9 workbook is at the bottom of your Spring 2020 folder, and that is where the link to your textbook is as well. Okay, so you guys can be looking for those couple things there. So I'm going to bust through these two examples real quick with you, and I would just watch these before you jump into your homework and then tackle it and get your week off to a great start. All right, here we go. So the first thing I wanted to remind you for working on this worksheet is you have a couple of Pythagorean identities that you're going to want to remember. One of those is your cosine squared plus sine squared is equal to 1. And then another one, which we're going to use just right now, in fact, with this, let's see if I can make this happen. We're going to use with this problem is this identity where you have 1 plus tan squared of x is equal to secant squared of x. So as you subtract the tangent squared of x, then we get 1 is equal to secant squared of x minus the tangent squared of x. Okay, so this plus right here, right, that's going to lead us down that path of using work like with cosine and sine for ellipses and circles. This minus right here is going to lead us down that path of using secant and tangent for a hyperbola. So we're doing one with a hyperbola just because hyperbolas have a lot of tricky things going on with them. So here we go. All right, so first things first, we're going to get tan of 2 divided by, or t divided by 2 by itself. So you can see from this first expression right here, and I'm just going to do some mental math with you real quick on this one. We're going to take x, we're going to add 2 to both sides and divide by 3. So this is going to be an x plus 2 divided by 3 is equal to tangent of t divided by 2. And then just subtracting 2 from this side, we get y minus 2 is equal to the secant of t divided by 2. So at this point, this is where we were creating our squared relationships by squaring both sides. So we're going to just square everything. And then I'm going to set up a subtraction because we really do want secant squared minus tangent squared. That'll help us to know which way our hyperbola is going to be opening, whether it's going to be vertical or horizontal. So let's start with what secant is. We know secant is equal to y minus 2 squared, so we're going to put that one first here. We're going to put y minus 2 squared, and that's just going to be over 1 squared. And what it's equal to, which is secant squared of t over 2, we'll put that there. And then we're going to subtract from that, our value of tangent squared. Okay, so you can see that this piece right here is starting to look a lot like our identity right here. And tangent squared is equal to x plus 2 squared over 3 squared. Okay, and we know this whole piece right here is going to be equal to 1. So just in the interest of saving some space, and also because I want to get over here to this graph, I'm going to magically get rid of secant squared minus tangent squared, and instead we're going to replace that with a 1. Okay, so ideally I'd have a little more space to kind of show you that substitution, but we're just going to go for it from here. So we know that the center of our hyperbola is going to be at what? Now here you have to be a little bit careful because your x term is coming second instead of first. It still is at a -2, and then 2 is going to be the center of your hyperbola. And because the x term is negative and the y term is positive, we know that our hyperbola will be opening vertically, right? So it'll be opening in the vertical direction. So we're going to try a little sketch here, okay? All right, so my center is at -2, 2. Here's my center. And because of the 1 squared with the y term, I'm going to be going 1 up and down from that center in the y direction. So I'm going to kind of mark that off. And then because of my 3 squared that is with the x term, I'm going to make my rectangular box that is going to be sort of my frame for my asymptotic lines, big word there. And I'm just going to build that rectangle, okay, with that shape. So one of the things you're going to want to remember about writing the equations of your asymptotes is that you can use, remember, what is called the point slope form of the equation. So y minus y1 is equal to m times x minus x1. We'll see this again a little bit later in our next problem. But all we need is the center point, a point that each of the lines passes through, and then the slope. So when you think of the asymptotes running through the center and the corners of your rectangle, and apologize, I don't have like a snappy snap to line thing happening there. The slope of each of these lines, the slope of this line going up from left to right is going to be a rise of 1 and a run of 3. Okay, so that's going to be a positive 1/3. And then the one that's coming down from left to right is -1/3. So you have a plus and minus 1/3 is your slope. And then the x coordinate of your vertex was a -2. And the y coordinate of, not your vertex, I'm sorry, your center of your hyperbola was 2. So these are the equations of your asymptotes. And the last step for drawing your graph would be to actually draw the hyperbola itself. And because, again, the y squared is your positive value right here, we are going to draw our graph from this vertex, and it's going to open in the y direction. Okay. And you still want to be responsible for knowing and understanding the difference between a transverse axis and a conjugate axis, that these 2 points would be your vertices. And then on this assignment, go ahead and make sure that you actually do calculate how far your focal points would be from the center. So remember, the focal point, the distance from the center for working with a hyperbola is going to be a squared plus b squared, all right? So basically we have 9 plus 1, or the square root of 10, is going to be the distance you would travel from the center to your focal point, both above and below that center, okay? So just kind of keep that in mind. I'd like you to throw that into your work. Okay, so that's the first worksheet. As we scroll up, I'm going to do one more problem with you. And this is the assignment. It is from pages 774 and 775. And the problem numbers are actually on the assignment link in Schoology. Number 29 was one of the problems. And then I went ahead and left these in because each of these pieces where it has x equals h plus a secant theta and y equals k plus b tangent theta for a hyperbola, these are nice for you to look at just so you kind of know the direction you're going when you start with something written as a parametric and you're eliminating the parameter in order to write your rectangular equations for the circle, ellipse, or hyperbola. So I just kind of make a note of these, that they are here. You might want to write them down somewhere. I think they will help you with your homework. Okay. So here's the goal for this particular problem. We are eliminating the parameter of t, and there gets to be a lot of letters in this particular proof. So just kind of watch carefully and we'll get through it together. All right, so this is our x value in terms of t. This is our y value along the coordinate plane in terms of t. Let me get that written down. Y sub 1 plus t times y sub 2 minus y sub 1. Okay, so again, just like any other time when we're eliminating the parameter, you want to get the t value by itself and then make a substitution. So I'm going to solve for t here, and what that is going to require is that I subtract an x minus or an x sub 1 from both sides. So I end up with x minus x sub 1, and then I'm going to divide it by this value that is tied here to the t value. Okay, and that whole piece now is equal to t. All right, so here's where the substitution comes in, and here's where we're going to just have a little bit of alphabet soup going on. So we're going to take this value of t and we are going to plug it in right here. All right, so I'm going to just kind of march down the page from this point. So we are going to end up with y is equal to y sub 1 plus, and then this very, very large value of t, which is x minus x sub 1 divided by x sub 2 minus x sub 1. You'll notice here that it is also being multiplied by y sub 2 minus y sub 1, and that can be written as a value over 1. So because multiplication is commutative, you can switch pieces back and forth in our numerator, right? What I'm going to do is I'm going to go ahead and I'm going to do a little swap here. And I'm going to switch out and rewrite this with the y sub 2 minus y sub 1 first in the multiplication, and the x minus x sub 1 second in the multiplication. So it's just kind of a rewrite. So it's going to look like this. Y sub 1 plus, and then here in the top, we're going to have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Oops. And then over on the outside now, we're going to have our x minus x sub 1. So some of you might already be kind of looking ahead and saying, oh, hey, I recognize this formula, because that is the formula for slope. And I can actually move my y sub 1 over to the other side by subtracting it. So as we kind of continue to do a little algebraic manipulation on this, and I make this substitution for slope, so m is equal to this whole value right there, right, for slope, times x minus x sub 1, you have just shown by eliminating the parameter that you have point slope formula, or the equation of your linear function when you eliminate that parameter for t. Whew. So that was a nice little kind of a proof. I hope you could follow that one. I think you need to try it for yourself on maybe question number 30, yes, in your homework, see how that goes. And remember, if you have any questions, we are going to be having meetings at 2 p.m. on Tuesdays and Thursdays. That's our kind of new time to meet. And again, meetings are totally optional. Don't worry, don't stress if you can't make it. Just if you have any questions, get a hold of me in a different way if that's necessary. And good luck, guys. All right, you are doing an amazing job.